For this video, we have a triple integral that we want to do. E is the region bounded by these four planes, and z is the function that we're integrating. So the first thing I'm going to do is sketch this region, and of course, as always, do a not very terrific job. Okay, so the plane x is equal to 0. This is just the yz plane. So it's just this plane right here. The plane y is equal to 0 is the xz plane. So it's this plane right here. And then the plane z is equal to 0. This is the xy plane. So it's this plane right here. And the hardest plane of all to draw is the plane x plus y plus z is equal to 1. So this is going to be a plane. The intercept on each axis is going to be 1. And this is the portion of the plane right here that we're interested in. Okay, and so this is like one wall. This is another wall. This is another wall. And then this triangular piece right here, this is like another wall. So it's a four-sided region that we're going to be integrating over. And so now what we have to do is we have to find the limits of integration. That's sort of the tricky part about problems like this, is figuring out what the limits of integration are. Now, you can organize this in any way you want in principle, but it's easiest for a problem like this to organize it where these two are going to be, the outer two integrals are an xy integral, and then the inner integral is a z integral. There's a couple of reasons for that. Sort of geometrically, what's happening is you're starting at this point and going up to the point that's on this plane here, this triangular piece of the plane. And so the z variable is going from z is equal to 0 up to z is equal to something. And we're given x plus y plus z is equal to 1. I just think it's going to be easier to have the z integral on the outside. So z is going to go from 0 to 1 minus x minus y, because that's what you get if you solve this equation for z. So also, this plane, x plus y plus z is equal to 1, this makes z a function of x and y. Same thing for x. It also makes x and y functions of z and the other variable. But I think just geometrically, looking at it, it makes sense to have the z integral on the inside. But like I said, it doesn't really matter for this problem. Okay, so now for the xy integral, let's look at what we've got here. So now I want to draw the xy plane. So this is the x-axis, this is the y-axis. And I want to draw this purple line. This purple line I want to draw over here. It's just going to be something like this. Okay, and this is the line y is equal to x. Or sorry, y is equal to 1 minus x. Why is that? Well, in this plane, z is equal to 0. So then x plus y plus z equals 1 becomes x plus y is equal to 1. In other words, y is equal to 1 minus x. Okay, and so x is going to go from 0 to 1. And for every fixed value of x, y is going to go from 0 to 1 minus x. So this is y equals 0 to 1 minus x. And then x goes from 0 to 1. And we're integrating the function z dz dy dx. Now, like I said, there's a lot of symmetry here, so it would have been just as easy to start to have the x or the y integral on the inside. In my opinion, just looking at it based on how we have things oriented, it makes more sense to have the z integral on the inside. But it's literally the same thing no matter how you do things. So do it whatever way you want to do it. You'll get the answer no matter how you do it. But changing the order of integration, that's just part of doing math.